a very simple topic, and it is very useful for the coming entrance examinations. So, how to calculate the number of microstates of various configurations, SPD configurations also here. So, we will calculate by using the simple formulas, and it gives the number of microstates in a simple manner. Right. So here the calculation of microstates we will discuss one by one. Right. So here generally the microstates we will obtain, or the microstates are comes from states, and the states are comes from terms, and the terms are comes from configuration of free ion. Right. So the microstates which are coming from states, and states which are coming from terms, and the terms are coming from the configuration of a free ion. Right. So here the config, what is the meaning of configuration of a free ion? So we will discuss the terminology which is involved in the determination of a microstate. Right. So what is configuration of a free ion? Right. So an electronic configuration, that means arrangement of electrons in an orbital, so we can call it a simple configuration of a free ion. Right. So this free ion means nothing but S1 configuration or S2, P1, P2. So like these configurations in the presence of inter-electronic repulsions. So these configurations are further turns into terms, further splits into terms, right? So what is inter-electronic repulsion? So inter-electronic repulsions means, student, the repulsions which are exist between electron and electron, so that is called as inter-electronic repulsion. So due to the inter-electronic repulsions, the configuration of a free ion which further splits into terms. Right. What is the meaning of a term? Right. The term is defined as an energy level of an atom specified by its electronic configuration is known as term. Right. So generally the term we can express in capital letters like capital S, capital P, capital D, capital Y. Right. So these terms are depends on the L value. So means that is total resultant orbital angular momentum. That means the term will decide the total resultant orbital angular momentum. If L value is 0, then the term is S. If L value is 1, the term is P. If L value is 2, the term is D. If L value is 3, the term is Y. Right? So the term is the energy level of an atom specified by its electronic configuration is known as term. Right. So these terms in the presence of spin orbit coupling. So spin orbit coupling means nothing but means the spin angular momentum and orbital angular momentum. So generally the electron has two types of motion. Means in an atom the electron has two types of motion. One is electron revolve around on its own axis, so it produces spin angular momentum. If this electron revolving around the nucleus, then it produces orbital angular momentum. So due to this spin angular momentum and orbital angular momentum, then we can say it is a spin orbit coupling, right? So due to the presence of spin orbit coupling, the terms are further splits into states, right? So these states are further converted into or further splits into microstate in the presence of Zeeman effect. In the presence of Zeeman effect means nothing but, student, in the presence of magnetic field, right? The microstates is the combination of spin magnetic quantum number ms and orbital magnetic quantum number ml of an electron is known as microstates. Clear, right? The microstates is nothing but the magnetic spin quantum number, spin magnetic quantum number, and orbital magnetic quantum number ml. So that is the combination of spin magnetic and orbital magnetic quantum number. So these are the terms which are involved in the calculation of microstates. Right. So generally in the calculation of number of microstate students, so we have three formulas. We will discuss one by one here. So this is the formula for the number of microstate. Here the formula is 4Li plus 2 factorial divided by q factorial into 4Li plus 2 factor 4Li plus 2 minus q factorial. So generally student, so this formula means the 4Li plus 2 factorial divided by q factorial into 4Li plus 2 minus q factorial. So generally this formula is applicable for the configuration with p to the power of n and p to the power of 6 minus n and d to the power of n and d to the power of 10 minus n. So this formula is applicable for this kind of configuration. For Pn and p to the power of 6n minus 6 minus n student, nothing but p1, p2, p3, p4, so on p6. Right here for the d configuration, that is d1 comma d2 comma d3 comma d4, so on d10. Right, so generally you can use the above formula, so you will get the number of microstates of various p and d configurations. Right, so generally it is look like L to the power of q student. Right, L to the power of q. So L means nothing but that is means orbital angular momentum, orbital quantum number. So that is L value is equal to 0, then it is S. If the L value is 1, then the term is P. If the L value is 2, then the term is D. Okay, right? So if the L value is, you can write here the small, okay, so the P, then the term is F, and here it is 4, then the term is G. Right, so here S, P, D, F, G. Okay, right, so here you can see student, so what is Q? Q means nothing but the number of electrons. So Q is equal to nothing but number of electrons in a given configuration, number of electrons in a given configuration, in a given configuration. So here by using the formula student, we will calculate the number of microstates of various configuration one by one. Right, so first of all we will calculate student. For I will start with S configuration student. For S1 configuration, so see, for S1 configuration student, generally the L value for S orbital, generally that is equal to 0. L value for S orbital, that is equal to 0 student. So the Q value is equal to 1. The Q value is equal to 1 student. Just you apply the formula, that is 4Li plus 2, right? That is 4 into L value is 0 student, that is 4 into 0 plus 2 factorial divided by 1 factorial into, so means 4 into 0, 0 plus 2 means 2 factorial, 2 minus 1 factorial, that give only 1 factorial. So therefore the number of microstates are 2. Right, for S1 configuration will give number of microstates are 2 only. Right, so next we will move to the P1 configuration students. This is very very important for P1, P2, P3 configurations. Many of times these questions was asked. Right, so here you can see for P1 configuration I will write, that is for P1 configuration you can see for P1 configuration student. So first of all, what is the L value for P orbital? That is equal to 1. Simply you can write the L value for P orbital, that is equal to 1. Simple, right? So here the Q value is equal to 1, right? Q value is equal to 1, right? So substitute these data into the formula, that is 4 into 1 plus 2 factorial, that gives 6 factorial divided by, so here the Q value is 1 factorial student, then 4 into 1 plus 2, that means 6, minus 1 factorial, that means 5 factorial. Right, so after simplification student, here 6 factorial we can write as 6 into 5 into 4 into 3 into 2 into 1 divided by 5 into 4 into 3 into 2 into 1 student. Right, so these get cancelled, these calculations cancel, then the number of microstates are 6. Clear, right? So this is a very simple formula, and it is very simple technique to determine the number of microstate, right? Next, student, here you can see generally P1 and P1 configuration and so P5 configurations will give the same number of microstates, that is 6, right? And so P2 comma P4 configuration will give the same number of microstates, 15. For P3 configuration will give number of microstates are 20, right? For P1 P5 number of microstates are 6. For P2 P4 number of microstates are 15. For P3 configuration number of microstates are 20, right? So this is about p orbital, right? Next we will move to the D configuration, student, right? Here for a D1 configuration I will write for a D1 configuration, student. So the L value for a D orbital, that is equal to 2, we know very well. So here we have only one electron, that means Q is equal to 1, right? So by using the formula, student, you can substitute, that is 4 into 2 plus 4 into 2, that means 4li plus 2 factorial divided by student. So that is 1 factorial into 4 into 2, 8 plus 2, 10 minus 1. So it is completely 9 factorial. So here you can, student, 9 factorial divided by, sorry, 10 factorial divided by 9 factorial. So 9 factorial get cancelled, student. So then the number of microstates are 10 only. Okay, right? So for a D1 configuration will give number of microstates are 10 only, right? Clear, student, right? So similarly, so D9 configuration is also, it gives 10 microstates only. So D1 and D9 configurations are same, right? Clear, right? Next we will move to the D2 configuration, student, right? Generally the D2 comma D8 configuration will give the same number of microstate, that is 45, student. So just use the formula, that means here 10 factorial is common, student, divided by 2 factorial into 8 factorial, student, right? So after simplification, that is, it becomes 10 into 9 divided by 2, students. So 2 ones are 2 fives are, so therefore it gives 45 microstate. So D2 D8 and will give the same number of microstate, right? Please focus, right? Next, for a D3d7 configuration, student, you can see for a D3d7 configuration, that is equal to, student, the number of microstates are 120, right? So here generally it is 10 factorial is common, then divided by 3 factorial into 7 factorial, student, right? 7 factorial, here the number 7, here also 7 get cancelled. The remainder is here 10 into 9 into 8, student. Here it divided by 3 into 2, student, right? So 2 ones are 2 fives are, and 3 ones are 3 threes are, right? So that is equal to, student, will give, so 3 into 8, 24, 24 into 5, that is equal to 120. So therefore the number of microstates are 120, right? Similarly, students, similarly for D4 comma D6 configuration will give 210 microstates, and D5 configuration will give 252 microstates. So these all are the various configurations of S, P and D configuration. So please remember the values and try to practice, and you will get the values are very quickly, right? This is one formula. Then we will move to the another type, how to determine the number of microstates of that various configuration we will move, right? Here you can see, student, this is the formula for various inequivalent electron, that is for inequivalent electrons, so means nothing but np1 and n-1 d1 type of configuration. So here this is another formula, student. So this formula is applicable for np1 n-1 d1 type of configuration. So means here we have a condition, that is if the p and q values are always equal to 1. So if the values are is equal to 1, then we can use the formula that is 2Li plus 1. So 2Li plus 1 into 2Si plus 1 into 2Lj plus 1 into 2Sj plus 1. So this is the formula you can use when the configurations are is equal to, means the configurations are showing only one electron in their configuration. That is very, very important. Clear? Right. So here you can still students, so we have two different types of orbital. So for Li, for p orbital student, Li value for p orbital that is equal to 1, and Lj value for another orbital that is d orbital that is equal to 2, and Si for first electron that is equal to 1 by 2, Sj for second electron that is equal to 1 by 2, second orbital. Right? You substitute all these data into the above equation, student. So 2 into 1 plus 1 that is equal to 3, student. Right? Next 2 into half plus 1, that means half of get cancelled, then it becomes 2. Then 2 into 2 plus 1 that is equal to 5, and 2 into half plus 1 that is equal to, right. So here the total number of microstates are 60, right. For NP1 N minus 1 D1 configuration will give 60 number of microstates. Clear, right. Next we will move to the second concept, that is if the configurations are having P comma Q configurations with greater than one electron. So means here generally this formula is applicable for NP2 N minus 1 D2 type of configuration, right. So in this type of configuration we will use the formula that is 4Li plus 2 factorial divided by P factorial into 4Li plus 2 minus P factorial into 4Lj plus 2 factorial divided by Q factorial into 4Lj plus 2 minus Q factorial. So these are the multiplication of two different orbital configuration. Right here you can see, student, for Li value for first orbital that is equal to 1, we know very well. For Lj 2. Okay, right. So for Q value is equal, for P value for this configuration is equal to 2 and Q value is equal to 2. Right. So we will substitute all these data into the above formula, student. Here you can see that is equal to, student. So it gives 6 factorial, student. So 4 into 1 plus 2 divided by 2 factorial into 6 minus 2 factorial, that means 4 factorial, student, is multiplied with 10 factorial. So divided by same 2 factorial into 8 factorial only, right. So after simplification, student, it becomes 6 into 5 divided by 2 and into it is 10 into 9 divided by 2, right. So 2 ones are 2 threes are and 2 ones are 2 fives are. So means here it is equal to 15 into 45. So that gives 675 microstate, right. For NP2 and N minus 1 D2 type of configurations will give 675 number of microstates. So these are the three simple ways, way to determine the calculation of number of microstates of various configurations, right. So please remember the formula, student, which helps to determine the microstates of various configuration. So practice once and twice and thrice, you will get the formula is very quickly and the application process is very quickly, right. Next we will move to the another summary of the topic, student. Here the summary of the topic, right. So here this is the formula for the first configuration, that is for P1 P5 it gives the same number of microstate. For P2 P6 number of microstates are 15. For P5 20, D1 D9 10, D2 D8 45, D3 D7 120, D4 D6 210, D5 configuration is 252. So this type of right here. So the formula you can use, student, the formula you can use for this type of configuration, right. So for L to the power of Q type of configuration, student, you can use the formula that is 4li plus 2 factorial divided by q factorial into 4li plus 2 minus q factorial, right? So generally here you can see this is the second type. Generally the configuration with np1 n minus 1 into d1. Here the condition is p and q both configurations are having the same number of electron. So here we will substitute the formula, that is 2li plus 1 here. So this is the formula. You can substitute all the values, then it gives the number of microstates are 60, right? So if the configurations which are having greater than 1 electron, so for np2 and n minus 1 d2, right, here use the formula. Here this is the formula you can use, and it will give the number of microstates are 675, right? So this is the a simple topic, student, so which helps um, for the determination of a number of microstates of various configurations. Thank you.